Solving stoichiometry practice problems the easy way. In this video, we'll learn how to identify the limiting reactant, calculate the amount of substance produced, determine how much excess reactant is left over, and calculate the percent yield. To help us solve these problems, we will use dimensional analysis as our primary approach. Let's jump into a practice problem. In this example, we are told that 25 grams of silver sulfate react with 25 grams of iron 3 chloride. This produces silver chloride and iron 3 sulfate. So an example of a double replacement precipitation reaction. Looking at the balanced equation, we can see that for every 3 moles of silver sulfate, we'll need 2 moles of iron chloride. And this will produce 6 moles of silver chloride and 1 mole of iron 3 sulfate. We first want to identify the limiting reactant. In other words, which one of these reactants are going to run out first and limit the amount of product that is made. To find the limiting reactant, we're going to first convert the grams of each reactant to moles, then divide by their coefficients in the balanced equation, and then compare the two values. Whichever value is smaller will be our limiting reactant. Using dimensional analysis, we can convert our 25 grams of silver sulfate to moles of silver sulfate. We can also convert our 25 grams of iron chloride to moles of iron chloride. We can now take these values and divide them by their respective coefficients in the balanced equation. As we said earlier, for every 3 moles of silver sulfate, we need 2 moles of iron chloride. Comparing these two values, we find that silver sulfate is the lower number. This indicates to us that silver sulfate is a limiting reactant, and thus iron chloride is the excess reactant. This is a pretty good shortcut to identify the limiting reactant. However, you need to be aware that if you use this method, make sure you now eliminate these two values and instead use the number of moles as you move on to the next part of this problem. So now we've identified silver sulfate as the limiting reactant and iron chloride as the excess reactant. We now want to find out how much silver chloride will be produced in this reaction. Again, it's our limiting reactant that we want to focus on, as he's the one controlling how much product is made. So to find how many grams of silver chloride is produced, we want to take the moles of our limiting reactant, convert it to moles of product, and then to grams of product. So let's take the moles of silver sulfate that we found earlier, and using dimensional analysis, let's convert it to grams of silver chloride. We first want to multiply by the mole ratios that are found in the balanced equation. And if we stopped here, we'd be finding moles of silver chloride, but we want to take it one step further so that we can find grams of silver chloride. Multiplying by the molar mass of silver chloride will allow us to convert between moles and grams. And we find that we produce 23 grams of silver chloride. We may be asked to find how much excess reactant is left over. So because our limiting reactant is going to run out at some point, that means we'll have some of our excess reactant left over. To find out exactly how much, we can first go from moles of limiting reactant to moles of excess reactant, and then to the grams of excess reactant, following the same method we used previously. However, you should be aware that when we do it this way, we're actually finding how many grams of the excess reactant was used in the reaction. And if we are being asked how much is left over, we then have to take this amount and subtract it from what we started with. In this case, we were starting with 25 grams of our excess reactant. So again, let's take our moles of silver sulfate, which is our limiting reactant. We can multiply it by the mole ratio And then we can convert our moles of iron chloride to grams of iron chloride by multiplying by its molar mass. And we find that 8.6 grams of iron chloride is the most that would react with 25 grams of silver sulfate. So again, this is how much iron chloride would be used in the reaction. To find out how much is left over, we can just take our starting amount, subtract it by how much we used in the reaction, and that will tell us how much is left over. So 25 grams of iron chloride minus the 8.68 grams that were used in the reaction, and we find that 16.3 grams of iron chloride would be left over. Lastly, we may also be asked to find the percent yield of a specific reaction. In part 2, we calculated how much silver chloride should be produced based on our amounts of reactants. This is our theoretical yield. However, if you were to perform this in the lab, you may not get that exact amount. This is known as our actual yield. So to solve one of these problems, we need some additional information. In this example, they're telling us that a student performs this reaction in the lab and produces 20.5 grams of silver chloride. So the 20.5 is going to be the actual amount that was produced when someone performed this reaction. To find the percent yield, we want to divide the actual yield by the theoretical yield, and then times 100 to turn it into a percentage. So again, the theoretical yield is how much should be produced based on stoichiometry calculations, and then the actual yield is how much was actually produced when someone performed this reaction. Going back to our scenario, we're told that the student produced 20.5 grams, so that's our actual yield. And let's divide this by what we found in part B, our theoretical yield, which was 23.0, multiplied by 100 to give us a percentage, and we'd find that the student's percent yield is 89.1%. This means that the student produced less than what was expected. So remember, when finding the limiting reactant, you first want to convert grams of each reactant to moles, divide the moles by the coefficients in the balanced equation, and then compare the two values. The smaller number is the limiting reactant. And once we've discovered who the limiting reactant is, we no longer need these values. Instead, we're going to use the moles of the limiting reactant and convert it to grams of product using dimensional analysis. This is how we determine how much product is made from a reaction. We can also use a similar approach to find how much excess reactant is left over. Use the moles of our limiting reactant and convert it to grams of excess reactant. But remember, that tells us how much was used in the reaction. We then have to subtract it from the starting amount to find out how much is left over. And then lastly, to find the percent yield, we take the actual yield and divide it by the theoretical yield. I hope you found this helpful. Thank you for watching, and I'll see you next time.